Hello, I'm Susobhan, Assistant Professor of SVIST, and my department is ECE. Today, I'm going to discuss the basic features of Intel 8085 microprocessor as well as the internal architecture of Intel 8085 microprocessor. Before going to the architecture of 8085 microprocessor, I want to uh, describe some basic features or characteristics of 8085 microprocessor. Intel 8085 microprocessor is nothing but it is a 8-bit processor. This is widely used in the 1980s. Here are some key features of 8085 processor. According to the architecture and instruction sets, so it is a 8-bit processor obviously because it has 8-bit data bus and 16-bit address bus. Second one is it has 78 instructions including arithmetical, logical and control instructions, and it is also supports various types of addressing modes including some immediate, direct, indirect and indexed. Okay. Next, it has some general purpose or special purpose registers and memories. For example, it has 8 general purpose registers A, B, C, D, E, H and L, and flag registers obviously. Stack, it has 16-bit stack pointer supporting 256 byte stack, and memory unit which is supports up to 64 KB of memory. Okay, and it has some input output characteristics and interrupts driven characteristics, such as it has 256 IO ports and addressable using in and out instructions. Interrupts, it has supported up to 5 interrupts vectors using including RST0, 1, RST2, RST3 and RST4. So if we focusing on the control and timing sections of Intel 8085, here you can say that it has clock speed. It operates at a clock speeds up to 3 megahertz, and it is also supports various machine cycles including fetching, execute and memory access. Okay, and if we focusing on the packaging of this particular IC, it is available in 40-pin DIP, means dual in line package systems, and it has plenty of applications such as it is used as in embedded systems, some personal computers, robotics, etc. So now if we focus the particular block diagram which is known as the internal architecture of 8085 microprocessor, we can see there are several kind of units are there. Okay, Intel 8085 microprocessor has the following registers. If we observe this entire diagram carefully, you can see there is one 8-bit accumulator which is known as accumulator, which is sometimes it is also denoted by register A. Next, 6 8-bit general purpose registers. These are B, C, D, E, H and L. If we focusing on the right hand sections of this particular figure, we can see that one 16-bit stack pointer which is denoted by SP, then one 16-bit program counter which is denoted by PC, then instruction registers, and there are also some temporary registers. Okay, so now what is accumulator? So accumulator is an 8-bit register associated with the ALU. You can see this diagram carefully. If we see this diagram carefully, we can conclude that obviously the accumulator is connected with the ALU, which is known as the arithmetical and logical unit. It is used to hold one of the operands of an arithmetical and logical operation. It serves to one input to the ALU. Okay. The other operand for an arithmetical or logical operations may be stored either in the memory or one of the general purpose register. And obviously after doing some arithmetical and logical operation, the entire result would be loaded or placed in the accumulator. And now the general purpose registers means the 8085 processor contains 6 8-bit general purpose registers. They are B, C, D, E, H and L to hold the 16-bit data. A combinations of two 8-bit registers are basically employed over there. We can see that B and C, after combining B and C, it will be a 16-bit RP register pair. Similarly, D, after combining, it will be D register pair. Another one is HL register pair. Okay. So register pair means the combinations of two 8-bit registers. Okay. And these are the valid register pair which are already drawn over there. They are B, C, D, E and HL. Always remember, the programmer cannot form a register pair by selecting any two registers of his own choice. It is not possible. Okay. And another point is the HL pair is used to act as memory pointer, and for this purpose it holds the 16-bit address of a particular memory locations. Next one is the program counter. It is also a 16-bit special purpose register. It is used to hold the memory address of the next instruction to be executed. It is basically used as a tracker. That means it used to track the particular memory address where it is basically, from where it is basically called. Okay, so it is used as a tracker. The next one is stack pointer. It is also a 16-bit special function register. Stack is nothing but this is a sequence of memory locations which is set by the programmer to store and retrieve the data or the content of accumulator by using some particular instructions or mnemonics. And the main features of stack is it is basically works on LIFO technique. LIFO means last in, first out. This is called LIFO principle. During the executions of program, sometimes it becomes necessary to save the contents of some register which are needed for some other particular operation. The contents of such register in that case are to be loaded or saved into the stack. After completing the entire operation, the contents which were saved in the stack now brought back to the registers. Okay, and for this particular task, stack pointer controls the addressing of the particular stack. Stack pointer is denoted by SP. Sometimes it is holds the address of the top of the element. Next one is instruction register. Instruction registers basically holds the opcode or the operational code of the particular instructions which is being decoded or executed. Then the temporary registers, it is also 8-bit register. For example, it is associated basically, it is associated with the ALU and it holds the data during some arithmetical and logical operation. Thank you.